When we are factoring a polynomial, we need to remember what the word factor means. So a factor or factors are things that multiply together to give you an answer. Or factors, you can think of them as something your number is divisible by. So if we were talking about 12, our factors for 12, well, 12 could be 1 times 12. It could be 2 times 6. It could be 3 times 4. These numbers in here, these are all factors. So 1 is a factor of 12, 12 is a factor, 2 is a factor of 12, 6 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12. They're things that we can multiply together to get whatever number or polynomial we are looking for. So when we're factoring a polynomial, what we're going to be factoring out is a common monomial factor. So if you look at the problems in here, we did this first part together before you started the videos. But if we looked at our factoring polynomials problems, these problems look like the answers that we were getting from part 1 in this unit. So my answer looks like a polynomial. It has a y squared term, it has a y cubed term, a 3y term, and a constant at the end. When I'm factoring this, I'm looking for what was multiplied to each of these terms to give this result. So we're going to be using the distributive property kind of backwards. So instead of multiplying each term, we're going to be dividing. So I need to think, what can I divide all of these terms by? So I can't divide them all by y, because not all of my terms have a y. So if I look at the numbers, my coefficients here, I have an 18, a negative 15, a 3, and a 6. Well, I can divide all of these numbers by 3. So that's where I'm going to start. I will factor out a 3. So when I factor this out, I'm going to set this up to divide. So I'm going to draw an upside down division box, and I'm dividing each of these terms by 3. So 18y squared is getting divided by 3. Negative 15y cubed is getting divided by 3. 3y is getting divided by 3. 6 is getting divided by 3. So when I divide all of these, 18 divided by 3 gives me 6. I'm not dividing any variables here, so my y squared stays the same. Negative 15y cubed divided by 3 is negative 5. I'm not dividing any variables, so my y cubed stays the same. 3y divided by 3 would be positive 1y. And 6 divided by 3 is positive 2. So what this tells me is if I distribute a 3 into this new polynomial, I will get back to the answer I had up here. So now that I've factored out my 3, I'm going to look at this new polynomial and see if there's anything else I can factor out of here. So if I look at my y's, I have a y squared, a y to the third, a y, but there's no y on this term. So I can't factor out a y. I can't divide a y from all of these. If I look at my coefficients, I have a 6, a negative 5, a positive 1, and 2. Well, the only thing I can divide 1 by is 1. So if I divide all of these terms by 1, nothing's going to change. So I know that my GCF here is 1. That's the largest thing I can factor out. That means I am done factoring. I can't pull anything else out of that polynomial. So my final answer, I'm going to set up my two factors so that they look like a multiplication problem. So I know I can factor out a 3, and that would be distributed into this polynomial. And if I did this distribution, I would get back to the original problem. So my answer is 3 times 6y squared minus 5y cubed plus 1y plus 2. So we're going to use the same process to factor these other two problems. So each time I'm going to start by drawing my upside down division problem. So now I'm looking for what can I divide all of these terms by. So I have a 32, a negative 16, and a positive 8. Well, I know I can divide all of these by 4. So I'm going to factor out a 4. That means each term is getting divided by 4. So now I have 32 divided by 4 is 8x to the 4th power. Negative 16 divided by 4 is negative 4x to the 3rd power. Positive 8x squared divided by 4 is positive 2x squared. So now that I've factored out my 4, I look at the polynomial I have, 8x to the 4th minus 4x cubed plus 2x squared. Well, it looks like I can factor out a 2 from all of these. So I'll set up my division problem again. I'm dividing all of these, or I'm factoring out a 2 from all of my terms. So 8 divided by 2 would give me 4x to the 4th power. Negative 4x cubed divided by 2 is negative 2x to the 3rd power. 2x squared divided by 2 leaves me with 1x squared. So now I'm going to check again. Is there anything else I can divide all of these terms by? If I look at my coefficients, I have a 4, a negative 2, and a 1. Well, the only thing I can divide 1 by is 1. So I know I've factored my coefficients completely. Now if I look at my variables, I have an x to the 4th, an x to the 3rd, and an x squared here. I can divide all of these terms by x squared. So that's what I'm going to factor out next. So I divide my first term by x squared, my second term by x squared, and my last term by x squared. My 4 is going to stay the same in this division problem. X to the 4th divided by x squared, I subtract my exponents, so that's x squared. My negative 2 is going to stay the same here. X to the 3rd divided by x squared, well, that's just x. 1x squared divided by x squared, I'm going to have that 1, and x squared divided by x squared would cancel each other out. So this is all I'm left with. So now when I look at my polynomial I have here, 4x squared minus 2x plus 1. I already know I can't pull another number out of here. But if I look at my x's, I have an x squared on this term, I have an x on this term, but I don't have any x's left on my last term. So that means I can't factor out any more x's. So my final answer, I know if I multiply these three things together with 4x squared minus 2x plus 1, those are my factors. So what I have is 4 times 2 times x squared is being multiplied by my trinomial 4x squared minus 2x plus 1. Well, I can simplify this term in front of my parentheses a little bit. 4 times 2, that would be 8. So I would have 8x squared times 4x squared minus 2x plus 1. This is my final answer. This is my polynomial in factored form. If I check my answer for this, which I'm going to do because this problem was a little bit longer, so just to make sure I got everything right, to check my answer, I'm going to distribute 8x squared to each of these terms. So 8x squared times 4x squared minus 2x plus 1. 8x squared times 4x squared would give me 32x to the 4th power. Well, that looks promising already. That was the first term in my problem. 8x squared times negative 2x would be negative 16x to the 3rd. 8x squared times positive 1 is positive 8x squared. So my check, this totally works. This is the polynomial I started with. That was my problem. So that means I factored this correctly. 8x squared, if I multiply it into my trinomial, will give me this trinomial that we started with. So here you'll notice that I factored out a 4, and then I had to factor out another number. I factored out a 2. If I had seen in this first step that all of these numbers were divisible by 8, I could have factored out an 8 and saved myself a step in here. So let's see if we can save ourselves any steps in this last example. So my polynomial is 45x to the 3rd power y squared minus xy squared plus 5xy. So first step, I'm going to draw my upside down division sign. I'm starting with my coefficients. What can I divide 45, negative 1, and 5 by? Well, I could divide them all by 1, but that's not going to change any of these numbers. So I can't pull out any numbers this time. So now I'll start looking at my variables. What variable would have been distributed to all of these terms to get this answer? Well, I've got an x to the 3rd power, an x to the 1st power, and an x to the 1st power. So I can divide or factor out an x from all of those terms. So if I divide all of my terms by x, I am left with 45 x to the 3rd divided by x to the 1st is x squared. And then y squared doesn't have a y to divide with, so that would stay y squared. Negative 1 x to the 1st y squared divided by x. Well, my x's cancel out here, so I have negative 1 y squared. In my last term, my 5 doesn't have another number to divide with, so it's going to stay 5. X to the 1st divided by x to the 1st cancels out, so all I'm left with is y. So I factored an x out of all of my terms. Here's my results. If I look at this, I already checked my numbers. I can't pull out any numbers. I already checked my x's, so now I'm going to look at the y's. I have a y squared, and a y to the 1st power. So for all of these terms, I can divide out a y to the 1st power. So every term is getting divided by y. So in my first polynomial, 45x squared is going to stay the same. Y squared divided by y is y. My negative 1 will stay the same here. Y squared divided by y, well, that's still y. And in my last term, my 5 would stay the same. Y divided by y cancels out. So what I have left is a 45x squared y minus 1y plus 5. Well, I know there aren't any numbers I can factor out of here, and I've already factored out the x's and the y's. And I know I'm done because there's nothing else I can divide all of these terms by. So my final answer, my factors are x, y, and 45x squared y minus 1y plus 5. If I checked my answer, and you totally should, if I distributed x, y into all 3 of these terms, I'll know if my answer is right if I end up back at my original problem. So you have 4 problems on this side and a challenge problem to try and some IXLs to work on today. If you need help, raise your hand, let me know. I will come help you.